Okay, so in this video, we are going to talk about how to find the equation of a line based on a table or based on a graph or whatever sort of data they give you, how to find the equation of a line. And what we're going to do is we're going to build directly off of where we left off in the previous video. So if you didn't watch the video where I used the Lego blocks to make a pattern and talk about how we could describe that pattern with a table or with a graph, then you might want to go back and watch that video real fast. I'll put the link to it in the description down below so you can get to that easily. But once you've got that video down pat and you're comfortable with the way that we're using the table to describe a pattern, then what I'm going to do is move on from there into this video to talk about how we find the equation. All right. So with that said, let's get started by taking a look at our learning objectives. There's only really one learning objective, but we're going to approach it from multiple different perspectives, different sides, different facets, different things that we might see. So although there's only one learning objective, and that's to find the line, we're going to have to be able to do this a number of different ways. For example, it says that we need to be able to do this given any set of data. Okay, so the data that they give us, it might be in the form of a table. It might be in the form of a graph. It might be in the form of ordered pairs or coordinates for points. I'm just going to say points because that's the shortest thing to write. But they'll give you some points that are ordered pairs or coordinates or something like that. It could also be in the form of an equation, but we're going to talk about that in the next video. So right now we're really going to focus on these three things. And so my plan is to take a look at three examples, one where we use a table, one where we use a graph, and one where we use points. But you'll see as I go through those examples that really it doesn't matter which one they give you, because you can always flip back and forth and adjust and do what you need to do. All right. Now, I do want to review a little bit from yesterday as we get started though. So these were yesterday's learning objectives. Be familiar with the concept of a pattern or a rate of change or a slope. We said all three of these things are the same idea, just different words. And be familiar with the idea of an initial value, a step zero, y-intercept. These are all the same thing, different words, okay? And so what we did yesterday was we built this table out by building with Legos, playing with Legos. And what I want to do right now is this column right here, the repeated addition, this is probably the thing that most directly connects to the Lego blocks that I was working with. But this is a lot of writing. And so what I want to do is I want to try to abstract this concept a little. And to do that, I'm going to focus on this column right here. This column right here. Okay. And you may have noticed this already when we were talking about this yesterday. But the first thing that I want you to notice, in fact, I think I even said this in the other video, is that every single one of these lines starts with a 1. And the reason they all start with a 1 is because the pattern of Legos that I had one Lego block sitting right in the middle of it that never, ever, ever changed. Okay. They also have this pattern that every single equation has a 3 being multiplied by something. And I think I talked about this in the video yesterday, but where that 3 is coming from is that's how much it changes every time. Every single time it goes up by 3. And so when you add 3 over and over and over and over again, that's the same as multiplying by 3. So what we have to connect it back to that vocabulary is every single equation has, starting at the beginning of it right here, whatever the initial step was, the initial value, the step 0, the y-intercept, whatever term you want to use for that, value, I think has a U in it somewhere. Whatever term you want to use for that, they all have this. And they all have that 3, which is the pattern that we're seeing, that we're adding 3 blocks. Or we talked about it's how much it's changing. It's the rate of change, the rate of change. And then we also said you could call that slope. Okay, so whatever word that you want to call there, I think I talked about this in the other video. I'm pretty sure I did. Every one of those equations has an initial value in it. Every one of those equations has the rate of change in it. But the other thing that they all have, and this is the part that I want to focus on right now, is they all have this little number right here, 0, 1, 2, 3. And even though that number changes every single time, I want you to notice that it changes in a very consistent way. First of all, they all have a number, A, but B, that number changes based on the step, right? So this number right here tells us what step we were on, what step we were on. So when we were on step 1, I multiplied by 1. When we were on step 4, I multiplied by 4. On step 10, I multiplied by 10. Back here at step 0, I multiplied by 0. So what I have is I'm always multiplying by that step number. And in that video yesterday, we really kind of fleshed this out and talked about exactly where all these numbers are coming from. Now I'm just making an observation now that the numbers are here. So if you don't remember where these numbers are coming from, you might want to go back and watch that video again. Okay, but here's the other thing that's going to be really, really important to us. That step number is what we put on the x-axis. The step number is what we put on the x-axis. So what that means is I can take this equation and I can generalize it. Instead of just putting a number here, I can say it's always going to be 1 plus 3 times x, where x is our step number. Okay, so that's what our equation is always going to look like. So I've written all over this, so it's hard to see, but if I was to add to our table yesterday, I would say in general, on step x, we're going to have 1 plus 3 plus 3, and there's going to be altogether x 3's, which is going to turn into the equation 1 plus 3 times x. 1 plus 3 times x. Okay, now, actually, that's an expression, and it's not an equation yet. It becomes an equation when I put an equal sign. What would it equal? Well, the numbers that we have over here, these are the number of blocks, and we graph those on the y-axis is where we graph those. So in general, what does it equal? It's going to be equal to y. That's where we're graphing those things, on the y-axis. So I'm making an equation that builds out of this is what's happening. All right, so that's the first thing I want to start with for today's notes. What does the equation of a line look like? The equation of a line will look like, I'm going to write it the other way around just because that's traditionally the way we write it. So instead of stuff equals y, I'm going to put y equals stuff. And instead of putting the 1 at the beginning, I'm going to put the 1 at the end. Okay, but it needs a variable because it's going to change from problem to problem to problem. It's not always going to be a 1. So just like we did when we were solving equations and solving parabolas and stuff, I'm just going to throw in like ABC kind of thing that's going to represent a number. I'm just going to use a B. That's traditionally what we use as a B. And then over here, we know we're going to have the rate of change times x, right? The rate of change times x. And traditionally, the variable that we use to represent the rate of change is an m. That's traditional. Now, you might wonder, why do we use m? Well, it has to do with the fact that the person who invented this, Rene Descartes, he spoke French, and m meant something to him in French that means something sort of kind of like change. Maybe if you study French, maybe you can ask your French teacher about that. But so here's what we've got. The m always represents the rate of change, aka the pattern, aka the slope. Okay, that's what the m always represents. The b, that always represents our initial value, aka the y-intercept. Actually, I'm going to make these match. Usually when we're talking about pattern, we'll call it step 0. And when we're talking about slope, usually we'll call it the y-intercept. Okay, so again, all those words mean the same thing. So b is our initial value, or our y-intercept, or our step 0. M, that's our rate of change, or our slope, or our pattern. Okay, x's and y's, those are the numbers that we're graphing. Those are the numbers that we're plotting. In the context of the Legos, it was what step in the pattern we were on and how many blocks were in that step. But we're not always going to be talking about Legos. Sometimes we'll talk about, like, how many records do you buy and how much money do you pay? Or how long have you been driving and how far do you go? Or all sorts of things like that idea, right? So it's going to depend on the problem that we're looking at. But it's always x's and y's because that's what we graph. We graph x's and y's. All right. So this is what we're going to look at, which means to find the equation of a line, what this means is that if you want to find the equation of a line, you must find the slope or the pattern or the rate of change, whatever you want to do, call that. And you also must find the y-intercepts or the initial value or the step zero or whatever you want to call it. So there's two things that you have to find. There's two things you have to find. Now, it doesn't matter what order you find them in. Depending on the problem they give you, you do it in whatever order seems the easiest. It doesn't matter, just do it the way that's the easiest. But you must find those two things. All right, that's what you're gonna have to do. All right, so this is the basic idea for today. So like I said, I wanted to go through 3 examples. Here's our first example. All right, now if you need a second to write that down, take advantage of your pause button, stop the video, pause that, write that down if you want to. Find the equation of this line. Okay, so what I want to do is go back and look at our table. And from our discussion last time, I want to make sure that we understand we were able to find step 0 and we were able to find the pattern just by looking at the table last time. And so that's what I want to do right now is just looking at this table. Can we find step 0? Can we find the pattern? Okay, so remember what happened here is the number of blocks that we were adding every single time. That's how much this was going up by. So we started, initially we had 4 blocks in the first shape that I put down there. And then we put 3 blocks on it. So 4 plus 3, we had 7. And then we put 3 more blocks on it. So 7 plus 3, we had 10. So our pattern was that we were going up by 3 every single time. And that's where these numbers came from. So looking at the problem we're looking at right now. Now, oh, one more thing. Notice that it's the pattern in the y numbers that I'm looking at. I'm going up by 1s over here. It's the pattern in the y numbers that tell me how much I'm going up by. Okay, so here, and I look at the y numbers, how much am I going up by? So to find the slope, that's what I'm going to do first. And again, it doesn't matter which order you do these in, whichever seems easiest. I will say 9 times out of 10, especially with tables, the slope is the easier one to find, but it's not always, okay? So in the slope, I want to recognize that my pattern is, first of all, going down, right? So I'm subtracting something. That's the first thing. So I know that my slope, my pattern is subtracting something because the numbers are getting smaller. Now, how much did I subtract? Well, if I do 2 minus 5, I get -3. So I must have subtracted 3. And I can check this here too. If I do -1 minus 2, I get -3 again. And if it's truly a line, I'll get the same number everywhere I go. So I'm going down by 3. So that tells me that my slope, which we said we're going to use the letter M to represent slope, my slope is -3. And see how I'm just getting that right off of my table. Okay. Now, the next thing that we need to find is we need to find the y-intercept. Okay, the y-intercept, which was the same thing as step 0. So in my table, step 0, that would go right here. So this is the thing that I need to find next, is what number would go there? Well, if my pattern is going down by 3, if going from here to here, I went down 3, I can figure out what number I started with by just going the other way. Start at 5 and go up 3 instead. And I'll end up at 8. So this must have been an 8. So my step 0, which we said we were going to call B, is 8. So once I get those two numbers, now I take my equation, y equals mx plus b, where the m is, I'm going to replace it with what m was equal to. It was equal to -3. Where the b is, I'm going to replace that with what b was equal to. It was equal to a +8. And then the x is going to stay in x, the equal is going to stay in equal, and the y is going to stay a y. And so this is my equation. Sorry, that was cut off. Okay, so since that was cut off, I apologize. I'm just substituting in for m, what m was equal to. I'm just substituting in for b, what b was equal to. And then the y and the equals and the x, they all stay the same. This is a plus sign because b was positive. If b was negative, that would be a negative sign. Okay, so that's our basic idea using a table. All right, example number 2. We're going to go through this same process, but we're going to do it using a graph. Okay, so again, I want to go back to what we looked at yesterday for a minute. So yesterday we had these things. When we graphed these things, what we noticed is that there was a pattern here, right? The pattern was that I was going up 3 blocks every single time that I went 1 step over. Okay, so we talked about that this pattern that's created is that I'm going up 3 when I go over 1. And so that 3 that we had for our slope, we could write it as 3 over 1. Okay, up 3 over 1. So we've talked about, or we haven't talked about, but you've talked about in other classes, an easy way to remember this is the piece that's going up is the rise, and the piece that's going over is the run. Okay, I always run on the ground, run back and forth, run, 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 run horizontally. Run is horizontal on the ground, back and forth. That's where we run. If I'm rising up, I'm going in the air, I'm getting airborne, I'm flying in an airplane, I'm jumping. Rising up is going up. So my run and my rise goes up. Okay, and it's rise over run, rise over run. In the morning when you're sleeping, you have to rise up out of bed before you can go to a run. So the rise is going on top, rise first, and then you run. Rise up, run. Up, up is on the top of the fraction, up is on the top of the fraction. So rise up, then run. Okay, so there we go. So there is how we're going to find our slope. So once again, I'm going to choose to find slope first. Now on this problem, when you look at the graph, it seems like I probably could figure out without too much trouble what the y-intercept is. So that's why I say you do whichever one seems easier to you. But I'm going to do slope just because we just talked about slope. Okay, so I need to figure out my rise and my run to go from here to here. And for that, with a graph, you can literally just count. So my rise is 1, 2, I've got to keep track of how high I'm going. I'm going up to this line here. So 1, 2, 3, 4, 5. I rose up 5. So my rise is 5. And then over run, my run is going to the right. So things going to the right are positive. So I made this a positive 5 because I was going up, right? Positive things go up. Now I'm going to the right. So whatever I put in the bottom is going to also be positive because positive things go to the right. Okay. So how far do I need to go? There's 1, 2, 3, 4, 5, 6, 7, 8, 9. I went over 10. So my run is equal to a positive 10. So this is my slope. And then we just need to simplify it. Now you can type this into your calculator or change it into a decimal if you want to. I will say you're going to find when it comes to working with slope that fractions are definitely your friends. So I almost never write my slope as a decimal. There are some times on occasion, but almost never do I write my slope as a decimal. I almost always write it as a fraction. So there's my slope. Okay, so this is going to be the value of m in my equation. For my y-intercept, in this case, I can literally just read my graph. Okay, now it doesn't always work out that nicely. We're going to deal with how you might find it if it doesn't work out that nicely in a second. But in this case, I can just read my graph. My y-intercept is up 1. So b equals 1. So once I know m and once I know b, then I can take this equation. Y equals mx plus b. Y equals mx plus b. And where the m is, we're going to plug in 1/2. Where the b is, I'm going to plug in a positive 1. So since it's positive, it still keeps that plus 1. And there's my answer. There's my answer. So that's our second example. Okay. Now, there is one thing I want you to notice here before we do the next example. This is going to set us up for the next example. For the rise and the run, we can literally just count those things and that's fine. Okay, but you also learned back in geometry class and maybe even in other math classes that you can calculate a straight line distance by subtracting 2 numbers. Okay, so let's find real quick, what are the coordinates of this point right here? The coordinates of that point right there, Well, the over is going to be 1, 2, 3, 4, 5, 6. So it's a -6 because I went to the left 6. And the up is 1, 2, 3. So it's a +3 for the up. So there's the coordinates of that point. Okay. Now, what I want you to notice is that for my rise, for this distance right here, the -6 doesn't change, right? Because we're just going straight up. So the x value doesn't change because we're not going over. But the y numbers, they change. And if I subtract the two y numbers, 3 minus -2, I've got to do change. That gives me 5. And notice 5 is exactly what I got for my rise. So you should have learned back in geometry class that if you know two numbers, by subtracting those two numbers, you can find the distance in between them. So the distance between the bottom and the top point, in other words, the distance that I rose, is 3 minus -2, that's 5. So that also works when I'm going across, except for now, when I go across this way, it's the x number that's changing, the y number stays the same. So for my x number, I can take where I ended up at 4. I can subtract where I started, minus -6, change again. 4 plus 6 gives me 10. And notice that's exactly what I got for my run. That's exactly what I got for my run. So if we take that geometry concept and we apply it to this scenario, we're going to end up with a formula that you should have learned back in your last algebra class. And the formula looks like this. Formula for slope. Okay, so slope we said is m, that's m. And we already said that slope can be found with rise over run, and we're not changing that. We're still saying rise over run is slope. That's still the same. You have to rise before you run. That's still the same. Rise over run is slope. But here's the part that we're adding in based on this geometry concept. The rise is the final y value minus the initial y value, okay? So the rise is the final or the second y value minus the initial or the first y value. So y2 minus y1, that's my rise. And my run is the same idea, but it's with my x numbers. So my final x number, which would be x2, minus my initial x number, which would be x1, that's my run. So I can use this formula to calculate slope. If I have a table, I might be able to just count on my table. If I have a graph, I might be able to just count on my graph. But if my graph is so big that I can't count, or maybe the table has a big gap in it, like if we were trying to go from 6 to 10, if we were trying to go here, notice I can't just do 31 minus 19 and get 3. I have to take into account that we've gone 4 units. Okay, I've moved 4 spots. So I could use the slope formula to figure out the slope when my points in my table or the points on my graph are far apart from each other. Or what we're going to do right now is I can use the slope formula to find slope if I don't have a table or a graph, if I just have points. Okay, so this is what we would do if we just have points. So if we just have points, then the first thing I'm going to want to do is find my slope. So the question is, find the equation of a line that goes through these 2 points. So for my slope, I know I'm going to do rise over run. And we just learned that I can calculate the rise by subtracting the 2 y numbers. And I can calculate the run by subtracting the 2 x numbers, okay? Now, I will say as a side note, just as a side comment, the order that you put these things is important. If you don't have the orders right, you're going to get a negative slope when it should be positive, or vice versa, okay? So what I always do is I always label this. So here's my point number 1. Here's my point number 2. That means this thing right here is x number 1. And this thing over here is x number 2. And that means that this thing is y number 1, and this thing is y number 2. And so once I get those labeled, now it makes it easier for me to substitute. So for my slope, I'm going to get rise over run. I'm not going to write that again. I'm just going to jump right to my equation. y2 is 3. So in the top in the first spot, I'm going to have a 3 minus y1. y1 is -1. So minus -1. There's my top. In the bottom, x2 is 9 minus x1 is +3. So in the top, I can do change. I get 3 plus 1. So in the top, I'm going to end up with 4. In the bottom, 9 minus 3, that's equal to 6. So I've got a slope of 4/6. And we've talked about, like on the SAT, they don't make you simplify your fractions. So if you leave that as 4/6, I'm all good with that. I'm fine with that. If you're somebody who really likes to simplify fractions, if it bothers you to have that fraction not simplified, then we can simplify that. These both can be divided by 2. 4 divided by 2 equals 2. 6 divided by 2 equals 3. So I can simplify that. That's fine. And like I said, you could turn that into a decimal. You would get 0.6 repeating if you turned it into a decimal. But when it comes to equations, when it comes to slope, fractions are your friends. So I'm not going to change it into a decimal. So there we go. We've got our slope. Okay. Now we need to figure out the value of b. This is the part that's a little bit tricky. And there's a lot of different ways you can do this. And over the years, I've taught this a lot of different ways. But based on the discussion we've had here so far, the way I'm going to show it this year, the way I'm going to show it with you, is to go back to our equation. Let's use our equation. So our equation for a line was y equals mx plus b. Okay. Well, we just figured out m. We just figured out m. M is 2/3. So I can make that substitution. But I also want you to notice, I know x and y numbers. I've got 2 xy numbers here. I've got 2 xy numbers here. So because these are both x's and y's, and that's what goes into my equation, I can plug these numbers into my equation. Okay. Now, it doesn't matter which numbers you pick, as long as you pick them together. So either you pick both number 1s or you pick both number 2s. It doesn't matter which, but you've got to pick them as a pair. I don't like negative numbers, so I'm going to pick number 2s. Okay, you can pick whichever one you want. It doesn't matter. But I'm going to choose number 2s. So I've got y number 2 is equal to 3. So I'm going to take this y number right here. I'm going to replace it with y number 2, and that gives me a 3. Still have the equal sign. Okay. Now for my x number, I'm going to replace that with x number 2, which is 9. So I'm going to have times 9, and then plus b. So notice what happened when I did that is now I've got an equation that only has one variable, so I can solve that equation. So the first thing I want to do is simplify this. So I make this 9/1. So the 3 and the 9 can cancel. 3 divided by 3 is 1. 9 divided by 3 is 3. So then I have 2 times 3, which is 6. 1 times 1 is 1. And of course, anything over 1 is just itself. So now if I want to get b by itself, all I need to do is just subtract 6 from both sides. And it turns out that our b is 6 minus 3, or 3 minus 6, excuse me, is -3. -3. So now we know our b number. Okay. Now remember, our goal wasn't to find b. Our goal was finding the equation of the line. The equation of the line looks like this. And now we know what b is. And we know what m is. So we can plug those two things. X and y, we just leave x and y because it has to be able to describe all the points on the line. So my m is 2/3. My x I leave at x. My b is a -3. So I'm going to make this into a -3. And there's my equation. Okay. All right. So this is the basic idea for finding equations of lines. If they just give you 2 points, you can make a table with those 2 points. If you make a table, then you can do exactly what we did here and just start counting things out. Or you could grab some graph paper and make a nice accurate graph of those 2 points. If you do that, then you can just count up and over and things of this sort. and you can get the answer right from the graph, just like we did there. Or if they give you 2 points, you can use an algebraic technique where you use these two equations to find M and B. And then once you know M and B, you plug them in. Okay, so there's 3 different approaches that you can take. You can, in one sense, you can pick the one that seems like it's your favorite. If you're comfortable with all 3, then what you can do is just pick the one that seems easiest for the particular problem that you're doing. Okay, and that'll obviously will change from problem to problem. All right, so I think that takes care of our one and only learning objective. No matter what kind of set of data we have, tables, graphs, or points, be able to find the equation or the line that that data describes. All right, thanks for watching. Have a good one.